Suppose if you have to apply the pressure, then what happen? That liquid is going to be converted into the form of a gas. Same case it is happening with what? The deodorants. Suppose if you have to take the example, lot of the deodorants which is available into the market, then if you have to take the deodorant, then what happen? If you have to shake the bottle, then it will appear in the form of a liquid. But if you apply the pressure by uh, if you have to apply the pressure on the particular activator, then what happens? That liquid, it will convert into the gaseous form, and it will expel from the container. Okay, now this is happen, and now this is possible due to the liquefaction of gases. When the gas is initially the liquefaction means what? It is a process in which the conversion of a liquid to the gases, and that phenomena is called as a liquefaction of gases. And this liquefaction of gases is also known as this liquefaction of gas is also known as critical phenomena. Now in critical phenomena, again in critical phenomena or liquefaction of gases, what is the mechanism, how the liquefaction process it is takes place? Now in which what happen particularly, first you have to take the liquid uh, uh, at a room temperature, you have to enclose in a particular container. Okay, then if you have to raise the temperature, then what happen? The vapor pressure it will be increases. Then again, suppose if the vapor pressure it is increases, then what happen? That vapors are stick to the surface of an container above the liquid level, and at that stage the vapor pressure as well as an atmospheric pressure, both are the equal. Then the distinguished phase between the vapors as well as a liquid, it will disappear, and that disappear phase is known as liquefaction of the gases, or that distinguished point it is called as a liquefaction point, and now that phenomena it is called as a liquefaction of gases. Now that, or it is also known as a critical phenomena, and that critical phenomena it is takes place at its critical conditions. Now what are those critical conditions? One, critical temperature, critical pressure, critical volume. Then we have to think about the critical temperature, critical pressure as well as an critical volume. If it is critical pressure, then the temperature which is required for liquefaction of gas at that temperature is called as critical temperature, that is known as TC. And critical volume means what? The volume of one mole of a liquefied gas, and that volume is called as a critical volume. And then critical pressure, the minimum pressure which is required to liquefy the gas, and that temperature is called as critical pressure. Now the liquefaction of gas it is takes place at its critical temperature, its critical pressure, and its critical volume. And now that phenomena is known as the liquefaction of gases. And now that liquefaction of the gases, then there are different methods which is applicable for the liquefaction of gases. Now first method is known as Faraday's method, then second method Landy's method, third method Claudius method. Now these are the three methods which is applicable for the liquefaction of gas molecules. Now in first case what happened? In Faraday's method, Faraday is using ice as well as an salt mixture. It is used for the cooling mixture. It is used as a cooling mixture. And in second case, by applying some pressure, the gas is going to be liquefied, and now that phenomena it is called as a Joule-Thomson effect by using narrow jet. Then in case of an Claudius method, uh, the liquefaction of gas it is not only depend on the intermolecular force of attraction between the molecules, and but also it depend on what? Also it depend on the uh, also it depend on mechanical work done by the gas molecules. Now based on this principle, now we are going to focus about what are the different methods which is used for the liquefaction of gases. how the critical phenomena or the liquefaction of gas it is takes place. First, if you have if you have to seal the gas in a particular container, then uh, then wha- uh, then what happen, the temperature is going to be decreased and pressure is going to be increased. Then what happen, then the kinetic energy of molecule it is decreases, then density of the vapors which is equal to the density of a liquid, and now at that point the gas is starts to convert into the liquid one, and again and that mechanism it is called as a liquefaction of gases. And now we'll see, we'll discuss one by one. Now, first we'll go for the critical phenomena. What do you mean by critical phenomena? Suppose in critical phenomena, first point, consider a definite mass of a liquid at room temperature enclosed in a sealed tube. You have to take the gas and which is filled into the sealed container. Then the molecules from liquid phase evaporate and occupy the space above it. For example, if you have to take the cold drinks bottle and 50% of an cold drink, you have to drink it and then remaining part it is empty. Now you will clearly observe some of the vapors which stick around the bottle. Or also if you have to take the water and if keep as it is, then what happen, that vapors are stick to the bottle. Then the vapor pressure increases till the equilibrium is reached between the molecules escaping the liquid phase by evaporation and those condensing from the vapor phase. The equilibrium pressure is the vapor pressure of the liquid that at that temperature. If the temperature of liquid is gradually increased more and more, the liquid evaporates and vapor pressure goes on increasing. Then at a certain temperature, the density of vapors become equal to the density of a liquid, and the boundary between liquid phase and vapor phase are disappears. And in that fact, it is not possible to distinguish between both two phases. And now that phenomena is called as critical phenomena. Now that phenomena is called as a critical phenomena, and that critical phenomena it is takes place at its critical conditions. Number one is critical temperature. What do you mean by critical temperature? Because already I have discussed the critical phenomena or the liquefaction of gases, it is takes place at its critical conditions. Now, what are those critical conditions? Number one is the critical temperature. Number two, critical pressure. Number three, critical volume. Critical temperature. Critical temperature means what? The temperature of a gas may be defined as that temperature above which gas cannot be liquefied no matter how great the pressure is applied. Now at this point what happen, below its room temperature or the below its temperature or at a particular temperature, the liquefaction of gas which is takes place, and that temperature is known as critical temperature. Then critical pressure. If you have to think about the critical pressure, if the temperature at which the liquefaction of gas it is takes place, then you think about the critical pressure. Critical pressure means what? The minimum pressure which is required to liquefy the gas at its critical temperature, and that pressure is known as critical pressure. Means here minimum pressure which is required to liquefy the gas molecules, and that pressure is known as critical pressure. After the critical pressure, next point is a critical volume. Now, in critical volume it is defined as the volume occupied by a 1 mole of gas at its critical temperature and pressure is called as critical volume. Then The liquefaction of gas, it takes place at its critical pressure, critical volume, as well as its critical temperature. And now this is about what? This is about the liquefaction of gases. Takes place at its critical temperature, critical pressure, and critical volume. Then, yeah, after the critical temperature, critical pressure, and critical volume, we are going to focus about next point. Then we'll discuss about what are the different methods which is used to liquefaction of gas molecules. Now, first, there are three methods which is used to liquefy the gases. What are those three methods? Number one is known as Faraday's method. Number second, is a Lendy's method. Number third, Claudius method. Now, here this Lendy's method is also known as Joule-Thomson effect. First method is known as a Faraday's method. Now, in Faraday method, this method in which cooling is done with a freezing mixture. You have to use the freezing mixture. For example, ice as well as an salt, which is used as a freezing mixture. Then second one, in case of an Lendy's method, only the pressure it is applied, or with the help of the gas is compressed with the help of a narrow jet tube. And now that based on this principle, this Lendy's it works. And last one is a Claudius method. Not only depend on the intermolecular forces of molecules between the gas, but also it depends on uh, uh, the mechanical work done by the gas molecules. And now this is about what? This is about the basic principle behind the Faraday's method, Lendy's method, and Claudius method. I am audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, it is clearly audible. No?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, now next method. First method we will see the Faraday's method. What happened in Faraday method? Now, in Faraday's method, we are using a bent tube, and this is called as a reacting tube, and here ice as well as an salt mixture it is used for the cooling purpose. Now here you have to see, first you have to take the whatever the whatever the liquid or gaseous liquid molecule or the reactants which is placed at a one corner. Then you have to start the heating. Then what happen, if you have to start the heating, then kinetic energy of the molecule it goes increases. Then what happen, this liquid it starts to convert into the this liquid molecule it starts to convert into the gaseous one. And again, if that gas molecules it will pass from this point to here, then what happen, here due to the ice as well as an salt mixture, this liquid or whatever the vapors are there, that vapors are converted into the gaseous form. This is the apparatus which is used for the in Faraday's method. Now this apparatus it is used in Faraday's method. Here at the end we will collect the liquefied gas. Now how it is work? Faraday in 1823 used as freezing mixture of ice with various salts for an external cooling of gaseous molecules. In general, a gas can be liquefied by increasing pressure and decreasing the temperature. Increasing pressure and decreasing temperature. Therefore, Faraday succeeded in liquefying the gases such as ammonia, SO2, NH3, SO2, and Cl2 by generating the gas. Why Faraday? Next, the question it will arise, why Faraday's is liquefied only such a gases like NH3, SO2, Cl2 molecules. Now, why? Because the critical temperature of these molecules, it was nearer to its room temperature. That's why it is possible to liquefy the gases. Now, according to Faraday, Faraday succeeded in liquefying gases such as NH3SO2Cl2 by generating the gas by heating a cooling mixture and condensing the gas into the liquid under its own pressure, simultaneously cooling. Then Faraday could liquefy the gas like SO2, NH3 and Cl2 molecules because their critical temperature was nearer to the room temperature, and hence these gases could be cooled below their critical temperature. Already we know that critical temperature means what? The temperature at which the liquefaction of gas takes place, and that temperature is called as critical temperature. At a particular temperature, the liquefaction of gas takes place, and that temperature it is below its room temperature. That's why Faraday is succeed for the liquefaction of gases like SO2, NH3 and Cl2 molecules. The next point, Faraday failed to liquefy the gases like H2, He and NH2 molecules, nitrogen as well as an helium, then helium, hydrogen molecules. Faraday failed to liquefy the such type of an gases. Why? Because their critical temperature was much below than the room temperature. That's why Faraday is failed to liquefy the gases like NH2, He and uh, hydrogen, helium and nitrogen molecules. Suppose if you have to refer the GPAT question paper, and in some of the paper, the question which is based on Faraday liquefy the gases such as. Now there are examples which is given, options are given, you have to choose which one is the correct option. Or else Faraday's failed Faraday's failed the gases like. Then again options are given like SO2, NH3, Cl2 and He, helium. Then you have to choose your option, which one is the correct. Okay, then based on this principle, the Faraday it works. And now here, for liquefying a gas by applications of an pressure, it must be cooled below its critical temperature. This is about the Faraday's method, which is used for the liquefaction of gases molecules. Is it clear? This one, Faraday method.
Yes, sir.
Yeah. Yes, sir. Faraday, it is clear or not?
Excuse me, sir.
Yeah.
So, which kind of gas is used in the vent tube?
Sorry, in this band tube only those gas, its critical temperature, it's nearer to the room temperature, only that type of an gas molecule it is used in this band tube. Suppose for example SO2, then Cl2 and NH3 NH3 molecules only it is used for the liquefaction of purpose. But those gas molecule and its critical temperature much below than room temperature, that type of the molecules we are not using for the liquefaction of gas according to Faraday. But now next method it is applied after the Faraday. Landis it work on those molecules its critical temperature much below, and that type of a molecule it is liquefied by using Faraday principle. Okay. Yeah.
Yes,
Malika,
sir.
it is clear?
Yes, sir.
Yeah. Now, after this, only Faraday, what he has done, he has worked on only such type of an gases, whether its critical temperature, it is nearer to the room temperature only. And after Faraday, again, Landis it work on, suppose if Faraday's failed, then next scientist, that is Landis, work on that type of an gases he has selected, and then try to liquefy the gas molecules. Okay. Yeah, it is clear. Yeah, Malika, I'm audible.
Yes, sir.
Yeah,
Yes.
yeah. The next method, it is known as a Landis method. Now, this Landis method here, the liquefaction of gas uh, after suppose if the Faraday's fail to liquefy the gas such as helium, hydrogen, and nitrogen molecules, then Landis he has used such type of an gases its critical temperature much below than the room temperature. Okay, then in Landis method, what what is the construction of this Landis apparatus? It consists of an one expansion chamber. This is a expansion chamber. Now he is using a spiral tube. This is known as spiral tube, and this spiral tube which is connected with narrow jet tube, and this is a narrow jet tube. Then this spiral tube, it is connected with this spiral tube which is connected with narrow jet tube, and here, the refrigerating chamber, it is fixed and it consists of an refrigerating liquid, that is ammonia it is used. Then that same spiral tube, it is connected with what? Compressor. Okay. Now this is about what? This is about the construction of this Landis apparatus. Then what is the principle behind this Landis method? Now here Landis he has used the compressed gas is used for the liquefaction of an gases. Now here by applying some pressure, the increasing the pressure and decreasing the temperature, the liquefaction of gas it is takes place according to the Landis principle. Now what is the basic principle behind this Landis method? The compressed gas, the fresh air or the 200 atmospheric air is going to be passed from the compressor. Now here, if you have to see, this is a compressor. When we will pass the 200 atmospheric fresh air from this tube, then it will it will enter into the compressor, and then what upon the role of this compressor, it's apply some pressure, and that air is going to be passed towards the refrigerating chamber. Now here in refrigerating chamber, the ammonia it is used, and the role of ammonia, it reduces the temperature of that particular air. Then what happen? That temperature is going to be decreased here, and the pressure is already increased, but the temperature it is decreased when the gas is enter into the refrigerating chamber. Then the gas again it comes towards the it will pass from this tube into the expansion chamber through this spiral tube. Then now here what happened? Due to the increasing pressure and decreasing the temperature, the gas is going to be liquefied, but all the gas molecules are not liquefied properly. Then again what happened? Only the whatever the remaining molecules are there, that remaining molecules which expand into this expansion chamber, again that molecules are passed through this side tube towards the compressor, and this process it is a cyclic process until and unless the total molecules, whatever the gas you have passed from this pipe, it is converted into the liquid, and now afterwards, you will collect the liquefied gas into this chamber. And now this process, it is known as a cyclic process. This process, it is a repeated and repeated, and then only the total gas molecule is going to be converted into the liquid one. This is about Landis method, which is used for the liquefaction of gases such as helium, nitrogen, as well as an helium, nitrogen, and hydrogen molecules. And again, in somewhat the Landis is also failed to liquefy the such gases by using only compression of what, by only the compress or the pressure apply on the gas molecule. Up to the Landis, again Claudius it work on the liquefaction of such gas molecules. Then after this Landis, next is the Claudius method. Now we'll discuss about the principle of this Landis method once again. Landis in 1895 use Joule-Thomson effect as basis for the liquefaction of an gases. When a compressed gas is allowed to expand into a vacuum or in a region of low pressure to produces the intense cooling. In compressed gas, the molecules are very close and the attraction between them are appreciable. As the gas expands, the molecules move apart, then the intermolecular attraction must be overcome. The energy for it is taken from the gas itself, which thereby cooled. Means what happen? To increases the pressure and decreases the temperature, the liquefaction of gas it is takes place in this Lendes method. And based on that principle, Lendes has used 200 dry air is going to be passed from the pipe cooled by the refrigerating liquid such as ammonia. This ammonia it is used. Why? Because this ammonia it helps to remove the heat from that particular air. Here the heat is compression is removed, means the heat of compressed air it is removed. Then the compressed air is then passed into a spiral tube with a jet of the lower end. Then the free expansion of an air at the jet results in a considerable drop of the temperature. Means what happens when the gas is going to be passed into the spiral tube and the temperature is going to be decreased due to the cooling liquid it is used, and then the again that liquefied gas is enter into the expansion chamber, but all the molecules are not converted into the liquid, but some of the molecules are going to be converted into the liquid and remaining molecules are expand into the expansion chamber. And again that expanded molecules comes towards the compressor with the help of an side tube, and again this process it is repeated and repeated it is occur until and unless the total molecules of the gas is going to be converted into the liquid one. In further cools the incoming air of the spiral tube and returns to the compressor. By repeating this process of compression and expansion, a temperature enough to liquefy air is reached, and now the liquefied air is collected at the bottom of expansion chamber. The this is about the Lendes method, which is used to liquefaction of gases molecules. And after the liquefaction, after the Lendes, again Lendes he has failed to liquefy the gases. Then next, the Claudius it work on how it is possible to liquefy the gas molecules. Then, according to Claudius method, the liquefaction of gas it is not only depend on the intermolecular forces which present in between the molecules, but also depend on what? But also depend on the mechanical work done by the gas molecules. How the mechanical work done it was, and how the liquefaction of gas it is takes place according to Claudius method. Now we will see here, and this is again the same equipment which is used as a whatever the Lendes he has used, the same equipment now Claudius he has used, and now Claudius only what the modification he has done here, only the air expand push back piston it is going to be attached with the expansion chamber only. Now then here what happened, according to this Claudius method, the liquefaction of gases is more efficient than the Lendes method. Here also the cooling is produced by free expansion of compressed gas, but in addition the gas is made up of the gas is made to do work by driving an engine, and the energy for it comes from the gas itself which cools. Thus in Claudius method, the gas is cooled not only overcoming the intermolecular forces, but also depend on what? The performance of work, means the mechanical work done by the gas molecules. Then the liquefaction of gas it is takes place. That's why that is the way the cooling produced is greater than this Lendes method. Now here you have to see the diagram. Now here what happen, again same 200 atmospheric air is going to be passed, fresh air is going to be passed from this compression chamber, and the air is again enter into the refrigerating liquids in the refrigerating chamber. If it passes through the refrigerating chamber, then yeah, it will pass through this refrigerating chamber. Then due to the ammonia, what happen again, that gas is the temperature of an compressed gas, it is reduced, and that reduced temperature gas is passed towards this cooling tube, this spiral tube, and again passed into the spiral tube. And then what happen, then conversion it is takes place. Again here narrow jet tube it is used. The sum of the liquid is going to be converted into the liquid one. But those gas molecules are unable to convert into the liquid form, then that gas molecules are again enter into this air expand and push back piston due to the internal pressure. Due to the internal pressure, what happened, this pushback pistons here, it will push the air again into the expansion chamber, and that air is again passed to this compressor, and this process, it is a cyclic process, and again the total gas molecules are going to be converted into the liquid one, and this method is known as a Claudius method. Yeah, again now this the, in short we will see the working. Pure and dry air is pure and dry compressed air 200 atmosphere. It leads through the tube by cooling a refrigerating liquid to remove the heat produced during the compression. The tube is carrying the compressed air and then enter into the expansion chamber. The tube is bifurcate into the part of an air passes into the side tube into the cylinder of an engine. Here it expands the pushback piston. Thus the air does the mechanical work whereby it's cool. And then the air then enter into the expansion chamber and cools the incoming compressed air through the spiral tube. The air undergoes further cooling by expansion of an jet and liquefies. The gas escaping liquefaction goes back to the compressor, and whole process is repeated over and over again. Then the total molecules are going to be converted into the liquid one. Okay, now this is about what, this is about the Lendy's method, which is used for the liquefaction of gases. Now here the liquefaction part it is over. Now all three methods are clear. Hello, hello. Hello. Yeah, I am audible. Hello. Yeah, I am audible or not? Sagar. Yeah. Shraddhanand, I am audible. Hello. Hello. Okay.